Rust is a hydrated form of iron oxide. So corrosion, commonly called rusting, involves chemical change, including oxidation of metallic iron to iron-3 ions. What drives this spontaneous reaction? If we could zoom in close enough, we'd see that a steel object is made up of a lattice of iron atoms, with tiny lumps of carbon dotted through the lattice. Some of these will be exposed at the surface. If a lump is in contact with water, it will have contact not just with water molecules, but also dissolved salts and dissolved oxygen from the air. What we have here is a kind of natural galvanic cell. The carbon acts as an electrode because it provides a ready location for electron transfer. Here's what happens. When an oxygen molecule slams into the carbon, it grabs 2 electrons, which are dragged through the iron lattice from an iron atom. The oxygen readily reacts with water to form hydroxide ions. At the same time, the iron atom gives up 2 electrons to become an iron-2 ion, which is repelled out of the lattice and dissolves into the aqueous solution. Without access to this solution, there's no way for iron-2 ions to be formed. This explains why rusting happens much more slowly in dry conditions. Another method of coating is electroplating. This covers the iron with a thin coat of another metal, like nickel or chromium. These metals undergo a redox reaction to form an oxide, which, like aluminium, forms a barrier to further oxidation. If you put a lump of zinc in contact with your steel oil rig, you can see what's going to happen. It will be the zinc, rather than the iron, that's attacked. The moment any iron atom is attacked and loses electrons, it will immediately drag electrons from the more reactive zinc, maintaining its integrity as an iron atom. The zinc is acting as an electrode, one that's being used up or sacrificed. And because it's the electrode where oxidation happens, it's known as a sacrificial anode.